Introduction to sectional view. Every one of us generally eats fruit. We cut fruits into pieces to eat. So basically, in the language of engineering drawing, we have sectioned the fruit into pieces to eat it. As an example, we can say that when you cut an apple in half, it means you have sectioned it. Just as an apple object can be sectioned any way we choose. So in this video, we are going to discuss sectional views. Let us firstly discuss what actually is sectioning. Let's take an example. In this example, two blocks A and B result from the block in figure 1 is sectioned. So basically, we can say that sectioning is the process of drawing the internal configuration of an object by cutting it apart. And the plane which cuts an object is a cutting plane. Remember that the cutting plane is an imaginary plane taken through the object. Views obtained by sectioning are sectional views. So basically, sectional view can be termed as: a sectional view is a view on engineering drawing to show the hidden part of an object by cutting or removing some part of that object. Now the question arises, why do we need a sectional view? Needs of sectional view in engineering drawing. Sectional view is very useful when there is geometry on the interior part of an object. We have studied before that an orthographic projection can give top, front, and side view only. But it cannot give interior view. So to get the interior configuration of an object, sectional view is needed. Now sectional views have different types, and they are types of sectional views. The different types of sectional views are as follows. Full sectioning view, when the cutting plane passes through the entire object, resulting in sectioning object into two parts. The two views of an object obtained are called full sectional views. Half sectional view, when cutting a plane passes halfway through an object such that half-quarter part of an object is sectioned. The views so obtained are called half sectional views. Offset sectional view, when the configuration of an object that needs to be highlighted is not located on a straight line, then an irregular cutting plane is imagined which sectioned the object to give the desired view. The view obtained is an offset view. Revolved section view. This view shows the shape of an object by rotating a part of an object by 90 degrees. The view obtained in this section is a revolved view. Broken sectional view. When only a small part of an object needs viewing, then an irregular cutting plane passes through the object at desired depth. The view of the left section of an object is a broken view. Different sectional views are clearly shown in this video with their respective cutting planes. So, the obtained views give the desired configuration of an object. So that sectional views are very useful in engineering drawing field, because sectional view can give the interior configuration of an object. So if there is geometry in an interior part of the object, sectional views are useful there. In this video, we have discussed sectional views and got a clear idea about it. So we will come with sectional view questions in our next video. In the previous video, we have seen sectional views, sectional planes, and its types. We can all see that we can cut fruits in different shapes, different sizes. Similarly, we can cut all solids by placing sectional planes at different positions. In this video, we are going to solve section of different solids for different positions of section planes. There can be various positions for section planes. So we are going to discuss it in this video. Also, we will solve problems for different positions of solids. So let's discuss about every position of solid in detail. Number 1. section plane kept parallel to HP. In this condition, the section plane cuts the solid in such a way that the section plane is parallel to the HP or base of solids. In this position, the section plane is perpendicular to VP. In this condition, the section plane is projected on the top view. Number 2. Section plane parallel to VP. In this condition, section plane cuts the solid in such a way that it is kept parallel to VP. In this position, the section plane is perpendicular to HP. In this position, a sectional view is projected on the front view. Number 3. Section plane perpendicular to the HP and inclined to VP. In this condition, the section plane cuts the solid in such a way that it is parallel to HP and inclined to VP. In this position of section plane, sectional view is projected on front view. Number 4. Section plane perpendicular to VP and inclined to HP. In this condition, section plane cuts the solid positioning perpendicular to VP and inclined to HP. For this position of section plane, sectional view is projected on top view. Number 5. Section plane perpendicular to both HP and VP. In this condition, the section plane cuts the solid positioning perpendicular to both VP and also to the HP. In this position of section plane, sectional view is obtained in the side view. These are the possible conditions for section plane. Now let us discuss how to solve problems on section planes. The cone of axis length 50 mm resting on the ground on its base circle of radius 20 mm is cut by a section plane parallel to the base at a distance 30 mm above base. Firstly, write the given data in a drawing sheet. The radius of the base circle, let's say R, is equal to 25 mm. Section plane cuts the cone at distance 30 mm above base. The section plane which cuts the cone is given parallel to the base in the problem. So first, let's draw the top view. The top view of the cone is a circle. So draw a circle of radius 25 mm with center O and name the diameter chord as 17 below XY. So the length of 17 will be 50 mm. The projected circle is the top view of the cone. Now project its front view. Its front view is a triangle. For that, draw the construction lines in upward direction from front view, so that 1 7 is shifted in the front view such that it lies on the XY axis. Now mark point O above XY such that it is 50 mm above from the midpoint of line 1 7 because it is given in the problem that the length of the axis of the cone is 50 mm. Now join O-1 and O-7 triangle is formed. Here our front view of the cone gets completed. Then we have to project a sectional view. For that, let us consider a plane A' cutting the cone. In the problem, it is given that section plane is 30 mm above base and it is parallel to base. So draw a line A' indicating section plane parallelly 30 mm above base 1 7 The point where the line intersects the front view triangle, name that point as A'. So here A' is the cutting plane. Now it is time to draw a sectional view. The true sectional view of the cone as per problem is top sectional view. Because the section plane in this condition is parallel to base or XY, for that draw the construction lines from the front view. These construction lines should be drawn downward from A'. Now project these points on the top view as AA. Then taking O as the center and OA as radius, draw a circle. This will be the final sectional view of the cone. In this problem, we have seen that the true shape of the section is shown by the circle in the top view, whose diameter is equal to the length of the section, that is A'. This is also about different positions of the section plane. As we get different shapes of fruits by cutting it into different ways, similarly, we can get different views of a regular solid when it is cut by positioning section planes at different positions. In this video, we have seen all possible ways of positioning sectional planes, and where we will obtain a sectional view of solid like prism, cone, pyramid, cylinder and cube after the solid is being cut by sectional plane. So we have not discussed about sectioning sphere till now, so we will come with our next video, and in our next video we will discuss the section of spherical solid. In our previous videos, we have discussed sectioning solids like prism, cube, pyramid, cone and cylinder. In this video, we are going to study the sectional view of the sphere. As we know that fruits like guava, watermelon, orange all can be sectioned or cut in different shapes, as we can see in this image. These phenomena we are going to study on an object shaped like a sphere or ball. So first, let us understand what is a section of the sphere. So, when the sphere is cut by a section or a cutting plane, the obtained section is called a section of the sphere. Now, there are few things that we must know about section of sphere, and they are as follows. When a sphere is cut by a plane, the true shape of the section is always a circle. Another important thing that we should know is, if a cutting plane passes through the center of the sphere, then the two sections obtained will be a hemisphere, and the radius of the obtained hemisphere is the same as its height. Let us see now how the sectional plane or a view is represented. Sectional views are represented by filling 45 degrees angled lines having space 1/8 between them in section plane. Now there are different conditions for cutting spheres by placing cutting planes at different positions. So we will firstly discuss it. Condition number 1 for cutting plane is, the sphere is cut by a horizontal section plane. In this condition, the true shape of the section will be seen in the top view as shown in the figure. When the sphere is cut by a section plane A' parallel to HP, the section plane is called horizontal section plane, and the true shape of the section is a circle of diameter A'. So the true shape of the section will be seen in the top view such that the diameter of the section part is AA, and the width of the section will be the chord of the section circle, that is BB. It is clearly shown below in the figure. This is our condition 1 for section plane. Now moving to condition number 2. In condition 2, the sphere is cut by a section plane parallel to VP. This section plane is vertical section plane. In this condition, the true shape of the section will be seen in the front view. When the sphere is cut by section plane CC parallel to VP, the section plane is called vertical section plane, and the true shape of the section is a circle of diameter CC. So the true shape of the section will be seen in the top view such that the diameter of the section plane is C', and the width of the section will be the chord of the section circle, that is D'. It is clearly shown in the figure. So we have discussed the two conditions of positioning the section plane. So let's see one problem for the section of solids in engineering drawing. A sphere of 50 mm diameter is cut by a section plane at a distance of 10 mm from its center. Then draw the true shape of the sectional top and front view in the given conditions. Condition number 1. Section plane is perpendicular to VP and inclined at 45 degrees to HP. Condition number 2. Section plane is perpendicular to HP and inclined at 45 degrees to VP. In this problem, we have to draw a true sectional front and top view for two conditions. So let's see first for condition number 1. Firstly, write the given data in a drawing sheet. The diameter of the sphere, let's say D, is equal to 50 mm, so its radius, say R, is equal to 25 mm. Section plane cuts the sphere at a distance 10 mm above the center. Section plane in condition 1 is inclined at 45 degrees to HP. In condition 1, it is given that section plane is perpendicular to VP. So first, let's draw the top view. The top view of the sphere is a circle. So draw a circle of radius 25 mm with center below XY. The projected circle is the top view of the sphere. Now project its front view. Its front view is also a circle. So draw a circle radius 25 mm with center O' above XY such that it is touching XY. Here our front view of the sphere gets completed. Then we have to project a sectional view. For that, let us consider a plane G' cutting the sphere. In the problem, it is given that the section plane is 10 mm above center, and as per condition 1, it is inclined at 45 degrees to HP. So mark a point C', 10 mm above center O'. Now draw the 45 degree angle line through point C'. We can draw this line using a mini drafter or protractor. The point where this line intersects the front view circle, name that point as G'. So here G' is the cutting plane. Now it's time to draw a sectional view. The true sectional view of the sphere as per the condition 1 is top sectional view, because the section plane in this condition is perpendicular to VP. For that, draw the construction lines from front view. These construction lines should be drawn downwards from G', C', G' and various points of line G', G'. Now project these points on the top view as G, C, G and other points. Now mark the distance of these points from the front view by taking its distance from center O' by using a compass. Join these points with each other. We will obtain a sectional circle. This will be the final sectional view of the sphere as per the condition 1. This is the second method also to project the sectional part if you don't want to project sectional view in front view. For that, shift G', G' parallelly at some distance in upward direction. Now by using construction lines and compass, shift the other points of the sectional plane. We can obtain a sectional view here. In both methods, the true shape of the sectional plane is the same. So this is how we can project a sectional view of the sphere. This projection is for condition 1 of the problem. Now let us discuss sectional plane projection for condition 2 of the problem. Condition 2 is just a reverse condition of condition 1. So let us see the solution of condition 2. In condition 2, section plane is perpendicular to HP and inclined at 45 degrees to VP. Firstly, write the given data in a drawing sheet. The diameter of the sphere, let's say D is equal to 50 mm, so its radius, say R is equal to 25 mm. Section plane cuts the sphere at a distance 10 mm above from center. Section plane in condition 2 is inclined at 45 degrees to VP. In condition 2, it is given that section plane is perpendicular to HP. So first, let's draw the front view. The front view of the sphere is a circle. So draw a circle of radius 25 mm with center O' on XY line. The projected circle is the front view of the sphere. Now project its top view. Its top view is also a circle. So draw a circle of radius 25 mm with center O below XY line. Here our top view of the sphere gets completed. Then we have to project a sectional view. For that, let us consider a plane GG cutting the sphere. In the problem, it is given that the section plane is 10 mm above center, and as per condition 2, it is inclined at 45 degrees to VP. So mark a point C 10 mm above center O in downward direction. Now draw the 45 degree angle line through point C. We can draw this line using a mini drafter or protractor. The point where the line intersects the front view circle, name that point as GG. So here GG is the cutting plane. Now it's time to draw a sectional view. The true sectional view of the sphere as per the condition 2 is front sectional view, because the section plane in this condition is perpendicular to HP. For that, draw the construction lines from the top view. These construction lines should be drawn upwards from GCG and various points of line GG. Now project these points on the top view as GCG and other points. Now mark the distance of these points from top view by taking its distance from center O by using a compass. Join these points with each other. We will obtain a sectional circle. This will be the final sectional view of the sphere as per the condition 2. There is a second method also to project the sectional part if you don't want to project sectional view in top view. For that, shift GG parallelly at some distance in downwards. Now by using construction lines and compass, shift the other points of the sectional plane. We can obtain a sectional view here. In both methods, the true shape of the sectional plane is the same. So this is how we can project a sectional view of the sphere. This projection is for the condition 2 of the problem. Here our sectional view part of projection gets completed. We have studied all about projection, its views, its planes, sectional views of regular solid. So now we can easily project the true shape of anything in our surroundings that can be of any shape. We can apply projection of solids in our surroundings also. With this video, we have completed our projection of regular solids chapter.